Hey, hi, hello, vanakkam. This is our fifth lead code top 100 like two questions, and today we are going to see third problem, longest substring without repeating characters. This is from medium category, and we'll start from the description. Given a string s and find the length of the longest substring without repeating characters. Here we have a input. Input will be only one string, and we need to give a output as a number. Okay, we'll start the explanation. And I forgot to say that this is our next topic, sliding window. We have completed two pointers, four problems, and this is the sliding windows first problem. And sliding window is similarly same, almost same to type two pointers. In two pointers, what we do is will have two pointers. In two pointers, we move both the pointers towards each other, but sliding window is slightly different. We move both the pointers same direction until we get the answer. And we'll start an example, and you will get it very easily. This is our input. We want to know contiguous characters. It shouldn't give any repeating characters. For an example, if we choose this first four character, a is repeating twice, so it is wrong. But we need only unique characters should be there. Okay, so in this case we can take until c. So in this case we have three characters, but none of them are repeated, so it is correct one. And here also, if you see, all three characters are unique, and it's not repeated, so this two correct. You can take this bc also, this two correct. You can take bca, here also unique characters. But what we expecting is, we need to find the length of the longest substring. We need to find the longest substring. So in this case, you see here, right, bc only two characters. And if you see here bca, so this is 3. And abc, this also is 3 character, this also is 3 character. So we are expecting this only. So we should return which has longest substring. So 3 is the answer for it. In this case, in the second example, you can see that 5 b's, um, actually 5 b's are there. So it's all are repeating each other, right? So you can take only one character is not repeating, correct? So because it contains only one, that's why. And here you can see p w w k e w. You can have pw or wke kew. So here also you can see three characters are not repeating, so 3 is the answer for it. Okay, we'll clear the screen, and we'll start the explanation for it. So, as I said, sliding window is slightly different from two pointers. In two pointers, we would have our pointers one from one extreme and another from another extreme sometimes. But in sliding window, we will keep all the um, pointers, both the pointers, at the same place first of all, and we will move these pointers one by one, and if needed, then we'll move p1 as well. P2, I have initiated p1 and p2 at the zeroth index, first index, second. I have initiated p1 and p2 at the zeroth index. Now I'm going to have set. This set going to contain a unique characters, so that we can find if the value is unique or not. And I'm going to have a count. This count going to store the maximum element in this variable. Now how we can find it? This index represents a, correct? So this a is in present. This a is in present in the set. So we can add this a in the set, and we can have this count to 1, because 0 is the smallest. So our current count is 1. So current set count is 1. So maximum set count is 1. And then once I have added, then I can move the P2 because P1 is unique. So I can actually P1 is not in the set. So I have added this P1 and I'm moving P2. If you see P2 at the first index and P2's value, I'm going to check. First of all, I'm going to check P1's value again. If P1 value is already present in the set, then you don't need to check. You don't need to do anything, and you can check P2 with another condition. Check the P2, and if P2 isn't present in the set, then add it. So now set count is 2. So I'm incrementing this set count to 2. Once I have incremented, then I can move this P2 pointer one step forward. Now P1 is again checking. P1 is present in the set or not. P1 is already present, so ignore and go to P2. P2 isn't present, so I'm adding C into the set. Then I'm incrementing the count. Count is 3 now. And now I'm, as we said, once we added the count, then we should increment the P2, right? So I'm incrementing the P2. P2 is coming here and it points to A. Now again I'm checking that A is present in the set or not. A is already present, so ignore it. I'm coming to P2. P2 is already present, correct? So in this case, we are going to have a different condition. If P2 is already present in the set, then we are going to move P1 to one step forward. Before moving it, I'm going to remove this A. I have removed it, okay? I have removed it and I'm moving one step forward. After removed it, I'm checking that P1 is present in the set or not. P1 is present already. B is there, right? So I'm checking A is present or not. A is already, no, A is not present. So I'm adding A and I'm checking the count. Count is 3. 3 is already there, so ignore it. Now I'm moving this P2 pointer one step forward. Now I'm checking this P2 pointer. P2 pointer points B. And again my loop is continuing. When I'm checking the P1 already present in the set, so ignore it. But P2 also present in the set. So when P2 also present in the set, then I need to move P1 one step forward. Before moving that, I should remove B's existence from the set. So I have removed it and moving P1 one step forward. Once I moved, then again loops continues and P1 is present in the set. Yes, it is. And B is not present in the set, right? So we can add the B and I'm checking the count. Count is already 3, so it has already, so ignore it. And now I'm moving this P2 pointer one step forward. P2 is already present, sorry, P1 is present, so ignore it. P2 also present, so in this case we should remove, so we should move P1 pointer. Before moving that, we should remove the P1's existence. I have removed the C and removing the P1, moving one step forward. Now I'm checking again. P1 is present in the set, so and P2 isn't present, so adding P2 into the set. I have added. Once I added and checking the count length of the set and adding it. If it is already there, then ignore it. Then again I am moving P2 one step forward. When I move the P2, you can see, yeah, loop continues, and I'm checking P1 with the set. uh, P1 is already there, so ignore it, and P2 also present in the set. So in this case, I'm going to remove P1 from the set. I'm removing P1 and moving one step forward, P1, and loop continues. Again, I'm checking P1. P1 is present, so ignore it, and P2 is present. P2 also present. So again, I'm checking the P1. I'm removing the P1, removed, and moving one step forward. Now I'm checking the C. C is present in the set, so ignore it, and P2 is in present, so add the P2, and the count is lesser than 3, so ignore it. And then I am moving P2 pointer one step forward. Yeah, P1 is present, so skipping it, and P2 also present already, so moving this P1 pointer forward, and meanwhile removing the set. And I'm checking P1. P1 is available in the set, and P2 also available in the set. So in this case, again I am moving P1. Meanwhile, I'm removing from the set also. Now P1 isn't available in the set, so I'm adding B. We should move the P2, but already we have ended with our boundary, right? So already we have reached our boundary, so we don't need to move. That's it. We can end up this and just return the count. That's it. It's very easy, right? So we'll take one another example. I have written, and P1 is here, and P2 is here. P1 is pointing P. P is not present in the set, so I'm adding the P, and P2 also pointing the, no, actually whenever I'm adding P1, and you can directly move the P2 one step forward, P2. Now loop continues. Now P1 is already present in the set, so ignore it, and P2 is not present in the set, so you can add the P2. Now the set is, now the set has 2 length, so adding the 2, and now moving P2 one step forward, and P1 is already present in the set, so ignore, and P2 also, if P2 also present, then we should move the P1 forward. Before moving that, we should remove the existence from the set. I've removed it and moving P1 forward. Okay, P1 is W, it's present in the set. Then P2 also W, it also present in the set. So move the P1 forward and remove it. Now I'm checking the P1. P1 is not present in the set, so just add the W. Whenever you add the P1, then directly you can move P2 one step forward. Once we have added, then we can, yeah, our loop continues, and again P1 is present in the set, so ignore it, and P2 K isn't present in our set, so we can just add the K. Then we'll check the length is 2 is already present, so keep it, and meanwhile we can move the P2 forward. I have moved the P2, and now again loop continues. Then P1 is W, it's present in the set, so come to P2. P2 already present in the set, no, P2 is not present in the set, so just add the E, and take the length of the set and add this length to the count 3. Now move the p2 forward. When you move here, then you can see, yeah, a loop continues again. P1 is W, and it present in the set. Then check the P2 also present in the set, so we should move P1 forward by deleting it. And now P2, P now loop continues. K is present in the set, so ignore it, and P2, check the P2 is not present in the set, so just add the P2 into our set. Then take the count and store here and move the P2. But P2 we cannot move because there is no value. That's it. You can just return the count. And okay, we'll start the code on the PyCharm, and I will show with the debug how it works. Before that, we summarize it here. First, we need 2 pointers, P1 and P2. Both should be initiated at 0th index. Second, I need set. This is first, and I need set. Set should be initiated as a blank first of all, and then we can add one by one if we need it. And the third, count is required to add the count. First we can initiate as 0, and then we need a while loop. This while loop shouldn't allow P1 to cross n. Here n means the length of the string, and same to P2. P2 shouldn't cross the n. And fifth point, we have some checkpoints, like first if this if checks that P1 is present in the set or not, right? P1 is in, but actually what we are checking is P1 if not present, then we are adding and doing the operation, right? So this can be slightly changeable. Yes, P1 is not in set, then move and store value. Move P2 move and store the value. Then sixth point is LF. I'm using LF here. In this LF, I'm going to take P2. If P2 is not present, not in set, then P2, I'm moving P2 and storing P2. Here I'm storing P1. Okay. And seventh point, if suppose value is present, we can give that directly, like elif P1 is present. If P1 is present, then remove the value. Remove value from set. Remove value from set and move P1. 8. Return. Finally, you can return it. That's it. Okay, we'll move PyCharm and we'll start the code. Here we have initiated P1 and P2 to zeros, and we have length of value, which is n. This value represents the input, and we have initiated a count to 0, and we have a set. This is an empty set, and we have while loop. This while loop checks that this while loop makes sure that P1 and P2 shouldn't cross n. so that we don't get any out of boundary error. And this 11th line represents that our check. This is one of our check, which this checks that value p1 is not in the bank set is not in the set. If it is not, then add the p1 and move the p2 one step forward and take the count and store it in count. And elif has a val p2 and is not in the set, then if it is not in the set, then just add it and move the p2 pointer one step forward and store the count, store the maximum count. And lf, this lf we are checking that p2 is present in the set bank or not. If it is present, then just remove the p1 and um, increase the p1 pointer, and finally you can return it. So here we have only one while loop. This while loop checks that p1 and p2 shouldn't cross each other. That's it. No, actually it shouldn't cross the maximum length. And if you see the time and space complexity for it, here I have only one while loop. This while loop just passes through the given input, so it just order of n and count is a return type, and this is the result we wanted. But in between we are storing set bank, so this set bank contains going to have n number of value, so space complexity is order of n. So I have written here, and I will push this code to GitHub repository, and I will give the link on the description. You can check out that. Okay, I'm just running it on debug mode. We'll see line by line. Okay, it started, and p1 p2 is initiated to 0, length is 6 and count is 0, set bank is empty. While loop while loop starts. If condition checks that, it checks that p1 val p1 existence in the set bank. It's not present, so it's just going to add. It's added the p. Now under p2 plus 1, it is incremented and adding the count. Again while loop starts, it checks the p1 value. It's already present, so we are moving to lf, and same to p2. If it's not present, just adding and adding the count. Then third time the w is already present, so we are going to remove the p1 and incrementing the p1. Again p1 points to w, so again we should remove the w and we'll add the w again. It's added now. Okay, w, and we expect e to add. Yeah, it's added. 3 is the count now, so this would be our answer. It's done, and answer returned. Now we'll copy this code to the Leet code, and I will verify that it's accepted. Yeah, it works. I'll give the problem link and the description, and I will give the GitHub repository as well. Thanks for watching, and we'll see you on 6th problem.